This is JVM.Compare. This talk is where we are going to try and compare benchmark performances of different JDK and JVM combinations. For those among us, what is a JDK and what is a JVM? Is there a difference? Anyone?
JVM is a runtime.
JVM is the runtime.
Excellent. So why would I want to compare JDK and not just JVMs?
They're different also.
Because the implementation of standard Java classes varies from JDK.
Excellent answer. Thank you. Thank you. I apologize for cutting you short, but excellent answer. The implementation of the Java classes beyond the API that the specs of Java provide can be different in different flavors of JDK. The Java specification just provides a broad overview of how Java should operate and what API constraints it should stick with. What it does not provide is how the implementation should look like. So implementations could be different. Certain JDK vendors could have improved performance or could have improved throughput or something else that they're looking for in their own version of the JDK. So it is imperative for us to actually, us as developers, know what offerings we have. And until now, at least until Java 8, we used to just rely on OTN, get the JDK down, and start using it and be okay with it. Subscription models have changed. There are a lot more new players out there, and we have a lot of vendors for JDK available. Hence, our need to actually come up with determining which JDK works best for us. How do we know? So my co-speaker at Devnexus is right here, Don Ruff. Don, please raise your hand. Don and I started going off. You can find his Twitter handle on his back. He's sitting up front. Don and I decided to go ahead and determine what Java works best for us, right? And let's get very quickly started. I'm not going to spend a lot of time on the slide. We're both Java champions. We both work at BNY Mellon. We represent BNY Mellon at the JCK Executive Committee. Been in the fintech for a long time. I actually am one of the jug leaders at one of the largest Java user groups in the world, NYJavaSIG. So a round of applause for yourselves. Thank you for being with us. Now, we're both very involved in open source as well. Awesome. So what is the session agenda today? Is we're going to look at comparing benchmarks for operations using Eclipse collections. How many of you have heard of Eclipse collections? Perfect, thank you. Appreciate that. And the JDK Java collection framework. What we're going to do is use primitive IntList, that is an Eclipse collection enhanced list on a primitive integer. And we're going to use list of integers from the JDK. And we also have an object called person that we create, and we're going to run benchmarks across them. We will show you what benchmarks we've run, and we'll also go into the results and show you how we tabulated those results to come up with what works in our favor and what doesn't. Now, your mileage may vary. What we saw for ourselves may not be what interests you. So we've left the source code open for you to go experiment yourself, change the benchmarks, run them, and get your alternates. So please feel free to do that. Now, rules of engagement. This was something that Don and I sat down very early when we started this last year and made a determination that we are running out-of-the-box benchmarks. We are not looking to tune any JDKs. We are taking it down like a developer would, download a JDK, run it, expect the performance to match what we wanted. Okay? All JDKs and JVMs that we see here are unbiased in how we treat them. Obviously, if you favor a certain JDK, there are tuning mechanisms which allow you to get more performance out of it. We are not catering to that in our benchmarks. Right? So no tweaks to VM options or flags, and the intent is to just test out of the box. So you simply download JDKs and you test them. Right? The intent is, how does it scale for an ordinary developer who's not tuning their JVMs? Why are we doing this? One, we want to show you the results. We are excited. And two, we also want JVM developers to know what shortcomings they have or where their shortcomings are. So we look to show them where things can be improved if they have a target audience for something. Some small disclaimers before we get started. JMH is very much tuned for OpenJDK and Oracle and for certain flavors of Azure. So if you use any other JDK flavor, such as an OpenJ9 or Dr. OpenJDK, you will actually see a warning that says your benchmark results are invalid. We do not support this, right? So compiler hints get disabled and your benchmarks are somewhat not accurate. So what we did to level the playing field is there is a system property called java.vm.name, and this is what the JMH drives off of to set up compiler hints. And we made it anonymous for all the JDKs that we used. We'll show you a slide where we see which JDKs we use, and we'll go to that next. But first it is important to know that we ran our benchmarks first as named JDK benchmarks, where we did not anonymize the VM name, and later as anonymous to see the difference, and the difference was significant, right? So we wanted you to be aware of this. JMH is a very good tool, but it's very biased at the moment. And we are looking to talk to the authors of the JMH to find out how we can de-bias it. There are seven disclaimers about the benchmarks. Benchmarks are usually hyper-focused tests. They test small portions of your code. They have hot paths, so if you repeatedly execute the same code, you actually get hot paths in the JVM, so they execute better. So you should not always just rely on the benchmarks, and you should also do independent testing. Benchmarks don't consider everything that goes on in the program, right? They only rely on throughput. They don't rely on startup times. They do not rely upon memory growths, etc. So these are variables that you should be aware of. So don't use this as scientific data, but as an initial data to find out how your JDKs differ and compare, right? And when you run your own benchmarks, we expect that you do the same. Treat this as raw data for something more thorough to be done later, right? But this is the first step, because we have so many vendors, we do not know which JDK we actually want to use. And this is a good step to get started. Hardware. So this is the Beast. Hello, Beast. And thank you, Don, for offering the Beast. The Beast is a Mac Pro. It is a 12-core machine with 64 gigs of RAM, and it is super powerful. And it can get super hot, right? So when we run these benchmarks, I happened to actually visit Don's office where he had set this Beast up. That room was toasty. So in winters, Don doesn't need to actually turn on his heater. He simply starts doing the benchmarks, and he has a warm room. Me, on the other hand, I have a little monster. You all see it. I ran a few benchmarks on this device as well. So this is a 2-core, and it's 16 GB. Now your question is, why did we run it on these two? These two are two extremes of what your computer applications could run on. We have something that is huge and powerful, and something that is mini and not so powerful. And we ran our benchmarks on both. These are the combinations of the JDKs we currently tested. Obviously, there is room for more. There are about 7 more JDKs that I would like to add, but we'll probably burn down the house if we do that. So we're not going to attempt that right now. We're looking for friends and family outside of our houses to help us provide us with containers where we can run this. So first off, we have Oracle JDK 11 standard. We have GraalVM Enterprise Edition. How many of you have heard of GraalVM? Awesome, thank you. There's GraalVM Community Edition, which is actually different from GraalVM Enterprise in how it runs, and we will notice that quickly. We have Adopt OpenJDK, which has 2 flavors. Adopt OpenJDK comes with what is called a hotspot compiler, which is what Oracle and OpenJDK use. But Adopt OpenJDK also has something called an OpenJ9 virtual machine, which is extremely memory efficient. How many of you heard of Quarkus? How many of you have heard of OpenJ9? They almost go hand in hand. They drastically improve your startup times, drastically improve on your memory growths, etc. They may not as much do in the benchmark space as, let's say, a GraalVM Enterprise would. So their motivational aspects are different in both, and we have to take that as an evaluation point. Then we use OpenJDK 11. This is sort of our Z-test, right? This is the baseline for us. OpenJDK is our reference implementation. So anything we compare, we usually should compare it against the OpenJDK 11, right? Yes?
Why is it 1102?
Okay, great question. Why is it 1102? Who supports OpenJDK? Which company supports OpenJDK? 11. Red Hat, thank you. Whoever said that, thank you so much. So Red Hat has a minor problem in that when they release newer versions of OpenJDK 11, they do not release a Mac version of it. So you have 1106 Linux version, 1106 Windows version, but no 1106 Mac version. So we are limited because both of these machines that we use in the testing are 1102. Thank you, now. Great question. Awesome. Then we have two which are slightly different colored font. Obviously you'll be wondering why they are in a different font. These are special. Earlier we had mentioned that we had not tweaked any VM or flag options, right? And we had not tweaked them, so we did not get any undue or unfair performance advantage. However, how many of you knew this? OpenJDK includes a Graal VM. How many knew this? Okay, so item number 7 is where I am running the Graal VM under OpenJDK. It's called the JVM.CI compiler, which is a Java Virtual Machine compiler interface compiler. Starting Java 11, it is possible for you to use OpenJDK as a shell and replace the underlying VM as long as you implement the compiler interface. Right? So they have actually made it interfaceable, which is awesome. So that is the Graal VM JVM.CI running under OpenJDK, which is actually an implementation of your Graal VM Community Edition. It is not an Enterprise Edition, so you should note that. And the last one is where Graal VM Enterprise Edition has a hotspot or a C2 compiler. Okay? This is where Graal VM supports an OpenJDK hotspot compiler within itself. So these are two special cases because there is a possibility you're running Graal VM, but you're only writing Java code. You'll probably be triggering the hotspot as well if you want. You could just turn off the JVM.CI compiler and you get Java results. There are times when it is actually beneficial to use the Java VM over the Graal VM. And we'll show you benchmarks where it is more useful. Any questions about the hardware or the JDKs that we compared? Awesome. So remember number 7 and number 8, which were different? These were the flags that we used. So I should have a, oh, here it is. Bear with me. I actually have a pointer. I should be using it. Okay, it works. Awesome. So we unlock experimental options, and then we enable JVM.CI, which is what is your Java Virtual Machine compiler interface. And therefore, we are triggering a Graal VM in OpenJDK because we are using the JVM.CI instead of the hotspot. In number 8, we use Graal VM, and we are using the hotspot instead. So we negate the use of the JVM.CI compiler with a minus. Notice there is a minus, which means we are removing the use of a JVM.CI compiler. You have a question? Yes, please.
Yeah, does this mean that you end up with the same behavior as a regular tiered compilation C1 and C2?
As should be expected. But no, the answer is no, because the way we run our benchmarks, we are jumping ahead, but let me just explain real quick. We actually build the Java code with whatever JDK we are testing it against. So consider it to be a greenfield environment every time we run our tests. We take source code, we compile it with the JDK that we are trying to run it with, and we run the code. So it's not already pre-compiled classes. Compilation is different for every JDK, right? So this combination may or may not yield exactly the same results as their equivalents in their pure forms. Okay, which is why this combination exists. But great question, thank you. So there is another little cheat. We ran these tests a couple of times. We conducted this session at Oracle Code 1 last year, and here's what we found out. When we ran the test and we showed the output, adopt OpenJDK, OpenJ9 performed dismally, and we were confused about what was going on. We then reached out and we found out two things. The first thing we talked about was the anonymization of the VM name. Anyone remember? 3 slides back we talked about this. Awesome. So we had to anonymize the VM name, and since we did not anonymize it, the benchmarks were completely skewed and we did not look at the log results to see that. Our bad. That got fixed. The other thing that we found out is that adopt OpenJDK J9 exists to speed up your startup time and to speed up your memory growth rates. It does not exist just for throughput. So one of the suggestions made by the OpenJ9 team was, if you really wanted to do our benchmarks and make us look like normal, you should also try to run every single benchmark with the heap sizes balanced. So when you start your application, your minimum heap size and your maximum heap size are equated. So heap never grows. So there is no involvement of the heap growth size, and therefore you do a comparison across all JDKs with the same heap size. Okay? This is another angle at looking at benchmark performances, and we agreed to do that because we are looking at both what is the general throughput and what is the throughput if the heap size doesn't change. So we have two sets of benchmarks. Now today I'm not going to be able to show you the second one because we're currently running those. We're actually setting those up to be run, and these things take a while. In the next slide you'll see how long they take. There is some benchmark math. We run 7 benchmark classes across 8 JDK JVMs. You saw there were 8 JDK JVM combinations. So these are 56 Maven executions. So 56 different cycles of Maven executing code and running the benchmark. Each class, each benchmark class takes about 1 hour. That is 56 hours of execution. So imagine, I have this laptop and I can't do anything on it for 56 hours. The rules of engagement are, while your benchmark code is running, you cannot touch the device because if you alter anything that consumes CPU cycles, your benchmark results will be skewed. So we have kept the devices pure and holy and untouched while the benchmarks were being executed. And it's very hard, it's the only device I have. So I spend a lot of time on Netflix. Thank you. Our rule of engagement was that we will use more throughput, seeded with different sizes. There are different benchmarks you can do. There's throughput, there are a few more. Throughput is the most important of all. Everything else is a corollary of the throughput. Throughput, if you have attended my garbage collection sessions before, is basically the amount of time you spend running the application and not doing something else. Something else could include memory growths, garbage collection, etc. So there are a lot of different, measurements that you can make, and we focus only on throughput because we want to see how long an application can be running using each JDK for a given time period. Now, we had 42 benchmarks across 8 JDK JVMs, that is 336 benchmarks. We ran it in 2 forks, so 672 executions for every single class. That's a lot, and the room did get hot. All right, now, I think this is the second to final slide, so I'm just going to quickly skip through this. These are the different benchmarks we ran. We ran 3 basic MapReduce operations: filter, sum, and transform. These are the 3 operations we ran on the integer lists. So filter basically filters out even numbers, filters in, sum of all integers in a collection, and multiply each integer by 2. Now there are 6 benchmarks, and the next, as soon as this slide is over, I'm going to show you some code where we see at least a set of benchmarks so you understand what these are. We use Eclipse collections, we use serial or parallel, we use lazy or eager, right? So different combinations. Yes, please.
Did you run the 6 benchmarks for one JVM, then all 6 for the next JVM, or did you run benchmark 1 for all 7 JVMs, and then benchmark 2 for all 7?
Great question. So no, the former. We ran all benchmarks for a given JVM at a time, and then moved to the next JDK and ran all benchmarks. That is the only way we could set up Maven to work correctly. Otherwise, it would be a nightmare to set up the scripts. And you'll notice from our scripts, it was already a nightmare. We'll go through that in a minute. So we performed 4 operations on the object. Remember, we had an integer-based benchmark and an object-based benchmark. On the object-based benchmarks, we ran filter. We decided to create a simple person object, a small, tiny object. It was not huge. It had a person with an age, height, and weight. How much, right? The first one just filters out everybody who is between 60 to 72 inches in height. So that's all we filter in, and that's an operation we perform. And then the next one, we filter all persons that are shorter than 6 feet, and then group them by their ages. Then we do in-summary statistics. This is a standard Java code. We are performing summary statistics on an integer, the max, min, etc. For age. Age was an integer, of course. And then we did a combined summary statistics, which is an integer summary statistic of age and double summary statistics of weight and height. Height and weight are doubles. Source code and the results are out there for you to pick up and dissect, run, do whatever you have to contribute to, and share any suggestions. We are happy to receive suggestions for improving this code. And I guess with that, this is one picture that is, this is Don's favorite picture. Anyone guess what this is? Anyone?
CPU.
This was Don's CPU while he was running the benchmarks. And so I go back to the toasty room. Anyways, on that note, let's go to the hands-on mode now. Any questions while I'm switching? No? Awesome. I'm going to assume silence means all of you are following along and are still interested, not dozed off. Okay, thank you, thank you. So,
Are you running all of them right now?
I'm not going to run all of them. We'll be here for 56 hours. No, we're not running it. We are going to show you a canned set of results, but you're welcome to run this at home. All I want to show you is if you were to run this at home, how do you run this? Right? You want to have a clean environment. You want to shut down everything that's running on the device where you're testing. Right? You cannot have, forget Java processes, you don't want to have any processes that hog your CPU. Adobe Acrobat Reader, I'm looking at you. Get rid of Adobe Acrobat Reader, right? So you have to get rid of a lot of things that have spiky CPUs. Those are the dangerous ones. So observe your graphs first, know which ones, or set up a container and run it on that, right? So you have to figure out what to do, but these are the essentials under the hood. The first and foremost, how many of you use Maven in earnest? What are tool chains? I saw so many hands. I am so excited now. What are tool chains? Anybody?
It's a way of specifying the location of your tools externally.
Thank you, Jean. I wish I had an award to give out, but thank you. So you can run different kinds of JDKs, for example, using Maven. And one of the ways you would do that is by specifying a tool chain. Here is an example of a tool chain. Let me just increase the font a bit more so you can see this. Lines 8 through 18 are what we are looking at as one example of a tool chain. I set up a type of tool chain of JDK, and I provided a version and vendor as two attributes on line 11 and 12. Now, these will be used elsewhere as conditional parameters to pick up the JDK home that is listed on line number 16. And that's how we set up a tool chain. There is a tool chain for Oracle JDK, one for GraalVM EE, one for CE, one for Adopt, and another for Adopt. And that's where we ended, and one for OpenJDK. So there should be a total of 5. Everybody okay with that? 6 or 5? 6. Awesome. So that's the first thing that I wanted to talk about. Next, let's take a look at our Maven form. And for this, I'm going to open up the structure because it's easier to look at the structure than. And for some odd reason, I don't know how to increase the font of my structure. So I'm just going to rely on magnifying it. Okay. So we have some profiles here. If you notice, is it visible all the way at the back? Can you see? Awesome. So we have profiles listed out here. You have an IntList profile and a person profile. We'll talk about those. And then you have some JDK profiles, Oracle JDK, Graal, Adopt OpenJDK, OpenJDK Hotspot. And then you have OpenJDK Graal and Graal EE Hotspot. So these are the different profiles that we are running, the IntList and the person object against. So for every single run, you will see 2 profiles. You will see a JDK and you will see either an IntList or a person profile, because those are the benchmarks we run. And then I have a Java information profile, which is what we do to test JDKs, and we'll take a look at that if time permits. That's not too important for this. Setup. This is important. So before you run anything, you want to do a setup, and a setup will help you set up all the directories that you need to get the results into. We first delete an existing benchmarks, and then we add new benchmark folders where your new benchmarks will get created. We also remove an output directory, and this is where all your Maven output is fed as text files. And we upload all this as evidence to what we did. And it's important to have this because someone would come back and challenge how we got these benchmark results in data and where they are, and they're all on the GitHub site for you to enjoy. Next up, we have an environment. Once again, I'm going to increase the font a bit so you can see what we're doing. I'm just setting up Java homes. I have an Oracle home, a Graal EE home, a CE home, etc. And since I use a Mac, I know exactly where they're located, and this is how we set it up. The only difference we did when we installed the JDKs is come Oracle, we just changed the name from JDK 1106 to Oracle JDK 1106, so it was easier for us to distinguish. Right? Everything else comes with a standard name, and it's very easy to parse those. Awesome. Then we have what is called a test JDKs, because how many of you use Catalina already? Mac, Catalina? Nobody? You do? Okay, awesome. So one of the things you will quickly find when you run new applications on Catalina is that there are security constraints that can destroy you. Your JDK stopped working and you have no clue why that is not working. So we have a README for this project and it tells you how to bypass those security constraints. But we had to be sure that the JDKs were working because we did not want to invest 56 hours and then find out that all the benchmarks were not run, right? It's not fun. So here's a little tester. All it does is it tests the Java version for each of those JDKs and just echoes them out. So you see the results. Not much, but it's a very handy tool. Then we have something called a runoff. This is a garish looking script that simply runs first the environment, which sets up the Java homes, and then the setup, which clears the directories and creates new directory structures, and then invokes every single JDK shell script. And we'll take a look at one JDK shell script to see how it looks like, how painful it was for us. So, we sourced the environment file, which is again important because sometimes if you start a new shell, you may lose the environment. So we have to resource the environment. We set the Java home to whatever JDK we use, and we set the path to that JDK for this shell. And then we print it out so we're sure, doubly sure. And then we run our mavens. So if you notice, the first one is a maven with the profile of Oracle and IntList. I'm running an integer list profile. And I am executing it using a Maven exec plugin, passing in the tool chains, which supplies me the JDK that I need for the profile, and I'll take a look at the profile, and we redirect the output. So I'm capturing all the Maven output. We do this. The next one runs, again, an int list for the sum. Remember, there were three operations we performed. There's a filter operation, a sum operation, and a transform operation. So we have three different execution plugins in there. The filter is a default. I have a sum and a transform operation. And I'm capturing the output as filter.text, sum.text, and transform.text, and so on and so forth. So these are the different Maven commands. Imagine there are 8 different shell scripts with almost similar things with different Java homes. And that's how we run this. So enough of the introduction. Very quickly, let's take a look at the classes involved. I'm going to only show you one so you get a gist of how we do things. So we set up a benchmark. How are we doing on time?
Good.
Am I going too fast, too slow? Should I change the pace a bit? Good? Awesome. Okay, so this is how we set up a single benchmark. This is an int list filter, and this has about 6 benchmarks running in it. There's a setup, obviously, and the setup is seeding your int list, integer lists for that matter, right? So we have a random number generator which generates any number from -1000 to 1000 and populates items in your list. The size of the list is defined in the Maven POM XML. Let's quickly jump to that. How many of, I saw a lot of hands raised for the Maven POM. A lot of people use Maven, so you understand properties? Awesome. So we set up properties to make it easy on us when we wanted to change from, let's say, 1,000,000 to 1,000 size. Earlier we had to go change Java code every time we did that, and that was painful. Instead, we just created a property file, and that property file is seeded from a Maven property. Here we have benchmark size of 1,000,000. If I wanted to run 1,000, I just changed this number to 1,000. We run 2 forks, and that's what is made obvious here. We do 20 warm-ups for every benchmark, right? So each benchmark runs 20 times. And then once the warm-up is done, we done 10 measurements. So total of 30 iterations or executions of a single benchmark, right? And when you do this 6 times, you end up taking exactly 1 hour. And that's where the 1 hour comes in, right? And we run this 56 times, so 56 hours is what our total math is. Now, I guess the other things I'm going to show you as we move along, but let's quickly look at this. So I have a setup that sets up and seeds your integer lists. I have a benchmark options, which is standard, which is done through a parent options, which you can take a look at. I don't want to spend your time on that. And here are the actual benchmarks. Right? Benchmarks are very simple. They are small pieces of code that, similar to unit tests, you put an @benchmark on top of a method, and you execute it using some execution plugin. It runs as a main, and once the main is run, there are some benchmark options that are triggered, and that benchmark options is what get run when you run this class. So here is one example of a benchmark. It says filter _ JDK _ box stream serial. A lot of words, but it's important, and it looks ugly because we underscored everything. The underscores are important because when you produce your benchmark data later, they come out as text files, and you SQL query them. We'll show you how to SQL query them, and you want to be able to query on individual parameters, which is why you have these underscores, so you can split the strings or tokenize them. Great. So what is this doing? You take a JDK list, which is your regular Java list, and it's an array list of the size, which is nothing but what we entered in the form XML, and you filter for even numbers, and you collect them. That was what we talked about when we mentioned this earlier. Same thing, every single operation is exactly the same. This uses JDK, this uses Eclipse collections, which is obviously much more simpler. How many of you use Eclipse collections? Okay, I want to see more hands the next time. Thank you.
I'm a little bit surprised that Dan is not using Eclipse collections.
I know.
So anything you want to tell us, Dan?
Oh, alright, I use it.
Fine. But those of you who haven't, please do take a look at it. It is, you will find from our results that it is actually very efficient to use Eclipse collections. And I'm not just here to sell it. You will see for yourself. That's it. Here is your Eclipse collections. We're just selecting anything that is an even number. It's as simple as that. You can do a comparison of how these two look. You'll know which one you want to use. But I'll leave that up to you. We do the same for parallels, and there are different models of parallels. There is a parallel stream in Java. It's a very interesting conversation we could have about parallel streams with Don after the talk, if you're interested. We have IntList mutable, and here we use a primitive stream. So we actually have primitive streams in Eclipse collections, primitive collections in Eclipse collections. And then we have box collections as well. So you have a choice in Eclipse collections, while in Java you don't. You're simply stuck with one, right? These are the different kinds of benchmarks we ran: serial, parallel, box, primitive, etc. And this is all these operations are simply taking in even numbers and discarding all odd numbers. That's it. And we're running benchmarks across them. I'm not going to show you every single benchmark, but this is how it is set up. All benchmarks do exactly the same thing using different technologies. Now for the fun stuff. So we run this. And I'm going to quickly jump to my GitHub where I can show you where this code exists. So you can visit that and try these out yourself. So this is our JVM.Compare code, exactly what we're looking at in IntelliJ right now. Source and your shell scripts and your testers and your tool chains is all out here. What we test, where we download the JDKs from, is also listed. What is also listed is the Catalina security issues and how you overcome that. How you set it up and how you use it is also listed in the README. So feel free, go through this, run it, but run it on a device that you're not using for something else. Please do not watch YouTube videos while you're running your benchmarks. It's not good, right? So once you have a clean machine that's not running much, you can run these benchmarks. And I'm reiterating this multiple times, my apologies. So as you can look from the little graph that you see, you have 64% Java code and 37% shell scripts. So there's a lot of shell scripting involved when you do benchmarks, and this is because of what all we had to tweak in order to get them to work the way we wanted it to. So you will see a lot of shell scripts here. They exist for a reason, right? Go through the shell scripts, and if you have any questions, feel free to reach out to us. We're on Twitter. Our Twitter handles were all over the presentation, and I'll share that even after this demo completes. Great. So this was the source code for running the benchmarks. The results are here in a separate package. They're called JVM.Compare results. And the way it is set up is, you'll see a JSON file. We'll talk about the importance of the JSON file in a minute. There's a README. This is the README document. And then there are individual results. So every time we run our benchmarks, we create a new folder and dump those results here, right? So if you were to run this, feel free to dump your results in the directly parallel to any of these. Rules of engagement, we want this to be simple for everybody. Everybody should understand what is going on. So the way we do this is, we copy the benchmark results in output folders from what we generate, and we create a small README so people know that this is for this benchmark size, these many forks, these many warm-ups, this JMH version, it's important, how many threads, what benchmark mode are we running it in, are we anonymizing the JVM name or not, and do we change the heap or not, right? Simple things that we talked about earlier, we're just capturing them so people are fully aware of what we're running. Any questions about what we did so far? Good. So I'm a bit nervous. If I don't hear anything, I'm worried that you're all dozed off. Are you all okay?
Yes.
Just checking.
Thank
Okay. So now for the fun part. That was the Java part, and Java was the easiest part of what we did. It was actually the fun part. We were able to code, we were able to have some fun, we were able to burn down some buildings. No, we didn't. But yeah, it was nice. I mean, we got to do some things and we understood what was going on. It was great. Then came the harder part of analyzing the data that we got back. That was a challenge. We used several tools. When we did this presentation earlier at Oracle Code 1, we used a tool called JMH Visualizer. Amazing tool. Amazing tool if you want to sit down and analyze what is going on with your benchmarks. Not great a tool if you want to share this with an audience. It's not easy to understand for an audience who's completely diverse in mind about what benchmarks should be, right? So we struggled with that, and we got a lot of feedback from a lot of the audience saying, hey, we enjoyed what you presented on the Java side, but your results, we couldn't understand them, right? And then we go to YouTube, and our session is recorded and posted on YouTube, same comments. It's like, hey, the presentation was great, we understood the benchmark, we did not understand the results. So we switched gears and started using, based upon a recommendation from a very good friend of ours, to use Apache Zeppelin. How many of you heard of Apache Zeppelin? Okay, it's a great data analytics tool. If you've used Spark, you're probably already using Apache Zeppelin, right? How many of you use Spark? So congratulations, at least you who did not race for Zeppelin, you're using Zeppelin. For the rest of you, if you have not used Zeppelin, how many of you attended the recent New York JavaSIG session on Jupyter Notebooks? Anyone? It's a great session. Apache Zeppelin is similar. It is a notebook-driven application. What is a notebook? This is where you can provide different paragraphs, and each paragraph could be either a Scala paragraph, a SQL paragraph, a Markdown paragraph. You could create any number of paragraphs and collocate them and run them together, right? So you have, let's run this real quick. And before we run this, I just want to walk you through this. Can try to increase the font. That work? Can people see this? Okay. I have a little bit of visual dyslexia, so white backgrounds not very visible to me, so pardon me. I can't see that clearly. I'm going to focus here. So here's a link to our results, JVM.Compare's results. We can't directly go URL, and that is a limitation of Zeppelin right now, and I'm trying to figure out how to do that. We checked out the code to our local, and it's currently on my users, projects, conferences, JVM.Compare results. So the same code as this, we just checked it out. And we did 4 different kinds of benchmarks. If you remember, if we look at the Firefox, we can see that we had a 100 named JVM, a 1,000 anonymous, 1 million anonymous, and 1 million named. The same directories are used here. You have a 100, you have a 1,000, a million, another million. So we just have different benchmarks that we checked out from GitHub. And we are giving it the size based upon which one we are running. This is going to be used in our data later, and I'll share that as we move along. We print out what we have executed. And this is basically the JDKs that were involved in the benchmarks, and I'll show you why you have to add these, because they are not in the benchmark data. Speaking of benchmark data, let's take a quick look at how it looks like. So we are looking at a 1 million anonymous JVM. Here are your benchmark results. Let's go to IntList filter. And let's go to the Oracle JDK IntList filter. And this is how your benchmark data looks like. So you have a benchmark. You have the mode is throughput. It's a single thread. You have 20 samplings. And you have a score of whatever the score is. Higher is better. Higher the score means better the benchmark. Error is the amount of times you had error rates encountered. Lower the error rate, the better, right? Why is this 20? Can anyone tell me?
Warm up.
You had 2 forks and 10.
2 forks and 10 measurements. Thank you. That makes it 20. Excellent. Yes, there are 40 warm-ups involved, right? But we don't need to mention that because warm-ups are not included in the results. Now, this doesn't tell me anything about this being an Oracle JDK now, right? So what am I doing? I know that the CSV file has that name, right? The CSV file has every other detail that I need. So in my benchmark analytics, I just am passing it a list of all these JDKs that I'm going to append to my data set as I'm creating it. I'm reading a dummy CSV file first, and this is important because I need to create a baseline. Let's take a quick look at the baseline. And the reason I'm sharing all this now is when you run your benchmarks and you want to execute Zeppelin, I want you to be aware of why you're running what, right? Bear with me. I think I clicked this. Okay. Here's your dummy CSV, and that's all it has. It's a dummy CSV, it has no data. But what it does is gives you the shape of your data set, right? It tells me what columns I have, and it's great because if I don't use this and I just ingest my benchmarks, I have created a data set that does not have a few columns such as JDK and size, right? And I need this dummy to hint to the compiler that there is more columns that I will be adding later. So after I add individual columns, benchmark mode, etc., I add more columns not from the CSV. So if you notice, there is a section here called data not from the CSV, and what I do is I iterate over the JDKs. I have the numbers, the 0, 1, 0, 2, 0, 3 for the CSV file, and I am pulling from a list of JDKs and appending it to the columns. I also append a size column, which is what we set when we specify the benchmark directory. And I collect all of these because these run in a for loop of 1 to 8, since I have 8 JDKs. So I have 0, 1 to 0, 8, 8 different JDKs. I am pulling in every single benchmark that I've created, star.csv from star, and I am creating a benchmarks view. This is a Spark paragraph in a Zeppelin notebook, right? And why am I telling you this? This Spark paragraph in a Zeppelin notebook is made available to you right here in the form of a JSON. Benchmark main CSV.json is benchmark main CSV. When you click this button and you export it, that is the JSON file it creates. And you can import it likewise by just going to Notebook and importing. There's a way to import. If you go to Home, it says Import Notebook. You pull in the JSON, it will create this on your local. Okay? And it's collecting all the data, and we can run this data because it's not going to take a lot of time. It's just parsing 56 CSV files. Once we do that, we verify that there are 42 benchmarks for every single JDK that we ran. We also verify that there are 6, 7, or 5 benchmarks per benchmark class that we have. And that we can verify individual benchmarks. Do they exist or not? Sometimes benchmarks may not have run. Sometimes you may have had some other issue. Something may have failed. We don't know. We want to be very careful. So we verify a lot of things. And then we run and show you the benchmark data. So rather than show you canned data, I'm going to minimize this. I'm going to reduce the size and rerun my entire benchmark. Okay, so here goes. Oh, did I minimize it more? Okay. I know it's not readable right now, bear with me, you've seen all this code, so I have the luxury of minimizing this, and you will be more interested in the results anyways. And this is what I'm going to leave you with, and I'll leave room for questions, but this is running. Hopefully it is running. Okay, it is running the code. So it produces a markdown first. This is a markdown paragraph. It tells you what this benchmarking results are for, how to use it, what to do. You have all the steps here. I don't want to go through the steps because we've just sort of broadly covered it. But you should be able to follow along because there are a lot of comments in what we do here. Excuse me. So this is getting executed. This is done. Verification that there are 42 benchmarks. Verification that there are 5 benchmarks when you do person combined statistics and 6 when you do IntList filter and so on. So we're verifying everything ourselves. And then you can do individual comparisons and say, does this benchmark exist? You get an answer, right? And here are the results. And this is the most interesting part. Remember those underscores in the method names? Those translated to these drop downs here. So I have a drop down full of benchmark collections. I have EC box eager serial, box lazy, primitive, and primitive stream. I have JDK box and I have JDK stream. I do this across IntList filter, IntList sum, and IntList transform. Those are the charting for IntList operations. I've created a notebook this notebook is available to you. You can run the benchmarks, or you can use the benchmarks that we already ran, and you can view the results and determine which JDK works for you. In some instances, you will find that you'll love Ground EE because it is the best. Higher is better. Remember, there's the throughput. Higher the throughput, the better the performance. In this case, Ground EE seems to do wonderful. Great. If you have a use case where you want to use eager serial and Eclipse collections, maybe you should use Ground EE. But maybe there is something else that you want to run, and you end up finding that Adopt Open JDK is better for you, right? For instance, in this case, Adopt Open JDK Hotspot seems to be the winner. So you have to determine which one you want based upon what choices you make in your code. So if you code in a certain way and keep it consistent, you will know which JDK works best for you, right? We are going to leave it very neutral. We don't want to make a decision. We are in process of adding more graphs to this, and one of the graphs we will add is across every benchmark, which one JDK is the most performant. So that's one thing we will add, but we want it to remain an unbiased opinion of ours, and based upon what we need, we're going to choose the JDK we want. The other things that we do are primitive IntList operations we already talked about. We have person summary statistics operations, and then we have person filter operations. So the three operations, you can execute each one of them, person filter and grow, across the different combinations that we provide. The Java code exists. You can take a look at the Java code to identify whether it matches your coding patterns. Look at its equivalent here, you will know which JDK works best for you. So we leave it unbiased at that point. With that, I'm going to wrap up. Yes, please.
I just wanted to ask, these results, this is incredible. First, I should say this is incredible.
Thank you.
The output of this, it sounds like it's like a three-dimensional data set.
Correct.
And I'm wondering, when you looked at that, did you see patterns sticking out that made sense, that were explainable or not explainable?
Yes, we did see patterns. They will become obvious as soon as I say them.
What was the question?
The question was, did we see any patterns emerge from the data after we ran these benchmarks? There were a few clear patterns, and some of them were based upon where we were running the benchmarks, and the others were based upon the volumes that we were running the benchmarks against. Those are the simplest and most obvious ones. Running on a small device, you want to run more serial, not parallel. Obviously, there's no point. And if you're running a small volume, you do not want to run parallels. In fact, it jeopardizes the performance. So don't use parallel much. The third and somewhat surprising, which also ties back to my other sessions of what we found, and the choices are yours to make. One second, there was a question here already. I'll get to you. Yes, please.
IBM Z-Series has its own Java. Is there any relationship to anything here?
So IBM Z series is a great Java. We could not use it on a Mac. So
I
yes,
understand that, but I was wondering if there was any way that you could add that to your testing.
we could. We are actually working very closely with IBM folk. In fact, most of the changes we made to Adopt Open JDK were after they did a thorough research of what was going on, and that's how we found out that JMH was so biased. So yeah, we are working with them. Our intent is to add more to this, but we have open sourced this, so it is not just us, but folks such as yourselves who will add more shell scripts, and we get more results out of it.
We're limited by the amount of hardware that we have, right?
Yeah, get a bigger piece of hardware.
Yeah, just go out to like, Best Buy, pick it up.
But yeah, Best Buy has a couple of them.
Hi, Elliot. Elliot was already there. Sorry.
How reproducible are these numbers? What are your error bars on
Excellent
these charts?
Okay, great question. It is not only your mileage will vary, even our mileage varies. So on a good day, you may get a different set of numbers. On a bad day, you may get a different set of numbers. We've tried it like 3 times so far, and there has been some amount of consistency in where we've seen Graal EE or Oracle JDK 11 or Adopt do very good in certain metrics and consistently so. I don't have all the data here because we just got the latest results, but the code exists and it is free for you to use. One thing I am going to point out for folk who are interested in doing this themselves, right? Real quick. Here are the steps on the same page where you saw the JVM.Compare results. You have steps on how to set up your own Apache Zeppelin. So if you want to run this at home, one advice, do not run the benchmarks if you're watching YouTube or Netflix or running some other Java programs, but executing this is okay. You just set up Zeppelin, it's a Tomcat container, and you can configure it very simply. You just download it, you change a configuration to point to a different port, and you just download the JSON file, and you're set up with your notebook. Point it to the data, and it executes the results for you. You can then go back to the code and compare and contrast which JDKs match up to what your expectations are. Across the 3 or 4 that we have, you will notice some consistency. But you will also notice some inconsistency because these are widely varying configurations. One where we have JVM names, the other where we don't have JVM names. You will notice that Adopt Open JDK performs very well in comparison to other JDKs when you take out the JVM name. That's because JMH is biased, right? When you run the 1,000 versus the million, you will see differences because how warm-up speeds impact how benchmarks get calculated. Smaller the volume, warm-up speeds don't come into play that quickly. Larger the volume, you get faster benchmarks. Serial parallel will remain consistent. However, these things will make a difference. So there are a lot of combinations. Like you said, like earlier some gentleman pointed out, there's a 3-dimensional, I think it was you who mentioned that. It's a 3-dimensional set of data, we just have to analyze what we need.
Chandra, do you still have
sorry.
the JMH visual?
I don't.
Okay.
It's all gone.
Yeah, so when we did the talk at Code 1, we used the JMH visualizer, which the graph that it produced very quickly for us, it wound up using a combination of, it was basically a line graph across multiple things. And the trouble is, like, typically when you see a line graph, you want to see, like, changes over time, and it was showing changes over JDK and JVM. But it was pretty much like incorporating like a 3D visualization in a 2D graph for us, because what you saw was each of the benchmarks, like let's say the IntList filter and like the IntList sum and IntList transform, along with the first ones, they were all on the separate same graph with different lines, right? So it's hard to, I guess grok that, as humans we like line graphs to be a certain way, so I think the audience had trouble with it, but it was really flattening that 3D aspect into a single set of line graphs.
So a combination of both the JVM visualizer and our Zeppelin notebook is probably ideal in that case.
I think at some stage it would be great if we could just get, figure out how to get a 3D graph out of Zeppelin, but it's going to be hard to even reason about that just because there's so much data.
So much data.
Is there any pattern you could see with regards to how multi-threaded performance was being handled? Anything regarding, multiple threads that are being executed over the CPU with small number of cores and then context switching that was causing difference in performance?
Okay.
Anything of that nature?
We did not. That is not a part of our benchmark set. However, nothing is stopping you from creating those benchmarks, changing the number of threads, because we currently run with a single thread. We are comparing JDKs and JVMs, we're not comparing Java code. So our focus is on how does the JDK JVM perform. But I understand your ask. On a single JVM, yes, I could try that, but if it's multiple JVMs, I'm more interested in how they react across one another when performing the simplest of operations. Right? So 90% of the time you will be stuck in a single thread model with no resource leakages or whatever is the ideal situation that you want to test. And that's what we got in our source code right now. But nothing is preventing you from adding more.
This is answering the question, but there is a blog I wrote of the 4 a.m. Jamestown
Highly recommended that.
that actually will show you for a single JDK like comparisons between serial and parallel, right? For basically for all of these benchmarks. So
What's
you can
that
actually,
blog called?
let me find it real quick. It's it's on my Medium.
Oh,
It's medium.com/Donrob. /Donrob.
Someday I'll learn how to spell your name down.
Oh, you're used to putting a the in front of it, right?
Yes. Okay, so it's somewhere here, so
Keep scrolling.
let's
I
just
blog a lot.
Jamestown.
Keep going.
Okay, it's not here.
Keep going.
It's slow. It takes its time.
Your Wi-Fi? I blog a lot. Keep going. There it is.
Yep.
You look for the Look for the picture of my dashboard when I was sitting waiting for a ferry at 4 a.m. in the morning.
Okay, my internet's, there you
Just
go.
click X on that, and it should let you through it, hopefully. There you go.
Awesome.
So if you scroll down, there are actually graphs in here. And it explains like the difference between eager and lazy, serial and parallel. Showing the code examples, keep going. You'll eventually see some graphs. So there's an example like filtering evens, right? So you can actually see here the difference between serial, parallel, eager, and lazy, but also primitive. And what you'll find is for certain cases, like where you even, I'm benchmarking on the beast here, right? So I've got 12 cores, but you'll find that basically there are cases where like when you use primitives, there's no point in using parallel. You're just wasting, well, you're heating up my office, let's say, but you're just wasting CPUs, right? Because the primitive operations are so fast, you should just keep it primitive. Don't box it, right? Don't try and parallelize. So you'll see stuff like that in here.
Thank you.
Cool.
I think my question is somewhere related to using parallel streams, where you said using a small data set can affect adversely with parallel stream. Can you expand on that?
Yeah, so when you parallelize, when you have a lot of content and you can divide and conquer and there's a lot and there is enough to schedule the threads. If you have a small set that can fit into one thread and you parallelize, you are actually taking away the compute power of even a single thread and spreading it across multiple. And that causes more resource consumption. If you want something that is small, stick to serial and get it done with. If you have a large set, you may want to consider parallel, but then again, you should consider the kind of device you're operating on, and if this actually scales. Once again, measure, execute, repeat. If you don't measure, you are not going to find out whether it is beneficial for you or not. Great. Any other questions?
I have a question.
Yes, please. Oh, this is scary.
So there were 7 JVMs that you were benchmarking.
8.
Eight JVMs.
Yes.
What were the support contracts for each?
That's a very interesting question. So, apart from GraalVM Enterprise Edition, there was no need for a support contract in any of those. We actually have a permission from Oracle GraalVM EE to run this benchmark. We did not ask for a support contract from any one of those.
Because in choosing a JVM, that's probably just as critical as performance.
Absolutely, yes. And I believe there is another talk that Keen and I conducted earlier about the various versions and vendors for JDK. That should cover that a bit.
I want to add something in answering Frank's question. So part of the reason you didn't need a support contract for some of those was because you weren't running a production service.
That's correct.
So when you're choosing your own JVM, that doesn't mean you can legally use all of these for free.
You can't use any of those for free except, you can use almost every one of those for free in a development environment. Oracle JDK, GraalVM EE cannot be used in a commercial environment unless you have a license. Adopt OpenJDK has a clause where you can run some of those, but I guess they also have a support and maintenance clause that is on the side. So if you don't take that, you're stuck high and dry. It's almost as good as running OpenJDK. So use caution, nothing is free. Java, the spec is free, everything else is not free.
You mentioned that you also had a garbage collection talk. I was wondering if you have benchmarks of the different JVMs in the face of garbage collection, especially like the positives.
Yeah, so we are doing the reverse of that when we do the XMS and the XMX equation, the new benchmarks that we need to run before Devnexus. So we're taking away the garbage collection problem, right? And so think of it like instead of measuring pause times, I'm just measuring throughputs, right? So when we negate those two, you get the garbage collection graphs. So it's possible for us to do that. We're just not doing it because we don't have two things. One, we don't have the resources to run so much. It requires a lot of resources, and we personally don't have the resources. So if some companies help us out, great, we can do that. And the second is If you were to run just these two and collect the graphs, you know the third. So x plus y equals z, we have x and we have z. We can calculate y, right? So those are the two thought processes we currently have. But if we get more resources, absolutely we can give it a shot.
Waiting for a garbage collection compare document.
Right, so earlier there was a question. These are the 8 JDKs we are comparing. I'll put it back on the stage, on the screen.
Okay, can I ask a question? I run Mac and Linux at home, but I imagine that in your workplace you're probably deploying applications to Linux.
Correct.
And I'm just curious, I've never really done performance stuff on OS X. Do you think that at the end of your 56 hours, for the first hour, you were doing the IntList filter on Oracle JDK 11. If at the end of 56 hours you then did that again, would you get the same results?
Yeah, so it's very interesting you asked that question. We asked ourselves that too. And we came up with some hacky way of solving that problem after talking to some Unix engineers. This is what we do. You run Oracle JDK and then you sleep for 10. That was our hack. So you sleep down the CPU, so bring it back to normal, and you're again running not just the benchmark, but the entire build of the classes. So you're cleaning up everything, rebuilding the classes and rerunning it. So will I get very similar results as soon as I run it twice? If I run all, semicolon run all? Yes.
If this were Linux and the machine had just been booted,
yep.
Then the behavior of Linux changes. You know, as
absolutely, you're right.
As a page cache.
Yeah, so there's a page cache, there is a warm-up.
Yeah, I don't know if the same is true in OS X or not.
That's very fair. So one of the things we should probably do, and the straight answer is no, we've not done anything more than I showed you. But one interesting thing we could do is randomize these. Would that solve your problem? Right? So
I'm just posing the question.
That's fair. That's fair. And that's a very good ask. I currently don't have the technical know-how how to do that, but I see your point. If we could randomize the order in which we run those JDKs, then probably we get a different set of metrics. I don't know, right? So that is something we can look at and think about. And if you have any contributions to make to that, I and Don and I will be very happy for it.
I'm just wondering, I was trying to understand. If we added another, we duplicated that first line, we just ran them a second time. That's what you want to see, right?
I'm just wondering.
No, but the order also matters in that case.
If the machine was freshly booted before you ran these, then would the behavior change?
That's fair. So we did reboot the machine before we ran.
It's a really interesting question because the whole thing about the Intel microprocessors that are getting hacked in the microcode is coming to our mind, where it brings the commands to be executed.
Right.
It sort of caches them. So you have data, and maybe it's caching some data also.
Correct. But the sleep cycles are usually used to wipe those out. Right. So that's what we found out is a poor man's hack at cleaning up some portion of what could be left behind. Right. So your CPU is allowed to go do other things at that time, and that's what we're doing.
But if all you're saying is go to sleep, it really doesn't have to do anything, right?
Correct. And this process goes to sleep. The remaining Unix processes are still running.
Okay.
Right. So that is a poor man's hack. That's what we were told, and that's what we're attempting. I mean, there are more complex ways of doing it. We just don't have the bandwidth to do that at this point. But we have to start somewhere, right? If we trigger this as a possibility, think about it like this. There existed nothing to compare JDKs before this. We were in a quandary because we did not, people asked us, which JDK should I use? You don't have a direct answer because you're like, I don't know, use the one you like. If you like that name, use it, right? That's not the right answer. And we're starting to look at what matters to us, and therefore we broadcasted that. What matters to us may mean nothing to you.
John's suggestion, I think, sounds interesting, where instead of sleep, you do something random for 10 seconds.
Right, we could do that. So we'll try to figure out if that works, and that's a great suggestion. I don't know if we have the time to do it by Devnexus, but that is definitely something we can put on our issue list, and we look for contributions. Are we still okay with time?
Oh, I was curious. I don't remember if it's mentioned, but like, was I know everything was running on a single thread.
Correct.
Is everything pinned to a specific core while running this test?
So we did not do anything to pin anything to a core. We just let the JDK determine that.
Okay.
Right? So I understand your question, but the moment you start going into that, you have to go much more deeper. You just can't pin to one core. You also have to make the application behave and not jump over to other cores when you're testing that. So that was the reason we tested on the mini, and then we also tested on the big device, so we get that change in measurement, right? We wanted to avoid, there's a 12-core machine involved and there's a 2-core machine involved, and we wanted to see how the behavior differed.
You have the picture of my cores?
Picture of Don's course. This is his favorite slide, just to let you know. He's going to spend about 10 minutes at Devnexus talking about this slide.
So you can see actually here though, like where a parallel test is running versus where a serial is. Right. So you can see when one benchmark ends and another one begins. What's interesting though is maybe the one on the left. There was some effect we were seeing where some parallel tests seem to only be using. So on my machine with 12 cores, there's 24 threads. Right. So there's actually 24 lines here with the graphs. We saw some tests that were only, oh, they're there. See the second column?
Don, you want me to highlight?
Yeah.
Oh, they're only using every alternate.
Yeah, you see that? Isn't that interesting? I was trying to read out, why is that? What's it doing? Because it looks like a parallel test. They're definitely busy, but you know.
So it's using the physical.
This one?
Not
The second one. So the first one actually is using everything. And you can see like go to the fifth line or fourth line. There you go. No, over.
Left.
Well, that one's using everything, right? That one the machine is definitely heating up. But yeah, that one's like every other thread is being used. So
Is this machine a single socket 12-core with hyperthreading enabled?
yes.
I love these questions, thank you. Can you show up at Devnexus and answer?
Okay, I think we're out of time. Thank you very much, Chandra.
Thank you.